In lesson 3-1, we're going to find square roots of perfect squares. When we talk about perfect squares, we're talking about any number that can be found using a square. So, like 2 squared is 4. So 4 is a perfect square. So if we make a list here of some perfect squares, we have 4, we have 9. 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, and so on. So those are all what we call perfect squares. So if 2 squared equals 4, then the square root of 4 equals 2. So using this square root, which is actually called a radical sign, this here is a radical sign. Finding the square root of a perfect square is the way to kind of work backwards, whereas multiplication and division are opposites. The same goes with finding a square and a square root. Those things are opposites. For example, if we were going to find the square root of 2 squared, the square root and the square kind of cancel each other. So the answer would be 2 because 2 squared equals 4, which then equals 2. So you can go ahead and do what's inside the grouping symbol, kind of like PEMDAS. Do 2 squared first and get 4, and then we take the square root of 4 and get 2. Or we just kind of consider both of them kind of canceling each other out, and we get 2. So finding the square root of 81, well, we know that 9 squared equals 81, so the square root of 81 equals 9. So what I'd have you do for homework is just copy the original problem. You know, if this was number 1 in your homework, you would just write the square root of 81 equals 9. I do anticipate that you know these basic facts, so you wouldn't need to show a whole lot of work here for that. Example 2, we have a square root of a rational number. Also up front, you'll notice we have a negative sign. So since the negative is outside of the grouping symbol, and I do want you to think of the radical sign as a grouping symbol, just like parentheses, we're going to go ahead and make sure that we have that in the end. We want to think of the square root of this whole thing as 16 over 81. Think of it as the square root of 16 by itself and also the square root of 81 by itself. So really, what is the square root of 16? We get 4, because 4 times 4 is 16. And the square root of 81 is 9, just like from the last problem. 9 times 9 is 81. So when I say the square root of the entire quantity, 16 over 81, we want to say 4 ninths, or 4 over 9, and we knew that it was going to be negative because we had a negative sign before. So there would be the answer. So for example number 3, we have 1.44. I know when I think of basic facts, I know that 12 squared equals 144. So I know I'm going to have some variation of a 1 and a 2. It's not going to be 12 because that'd be 144. I do also notice right out front that I'm solving for the positive and negative values, so it is possible to say that we can solve for 2 different values here, so both a positive value and a negative value by showing here with both plus and minus symbols. So again, going back to what our number is going to be, the square root of 1.44. Well, I know that 12 times 12 is 144, and I know that I want to have 2 numbers to the right of my decimal point. So thinking about what happens with multiplication, when I do 1.2 times 1.2, I know that in the end I'm going to have 2 numbers to the right of my decimal point. So 2 times 2 is 4, 2 times 1 is 2, and then I'm going to have a 0. 1 times 2 is 2, 1 times 1 is 1. So then I'm going to have a 4, a 2, and a 1. I'm sorry, 4, a 4, and a 1. And since there are 2 numbers to the right of the decimal point, I know I'm going to have 2 numbers to the right of my answer, so 1.44. So When I take the square root of 1.44, I'm going to get 1.2, and I'm looking for both the positive and negative values as indicated in front of the radical sign. For example, number 4, solve x squared equals 225. So again, you're going to want to copy the problem out of the book for homework tonight. So x squared, all right, well, to undo the square, just like before when we had 3a equals 9, we divided both sides by 3 to get a equals 3. Well, here we're not multiplying, we're not adding, we're not dividing, we are taking it to the second power. So we need to do the opposite of that and square root x squared. Because remember from the very first example, we know that those two things will cancel out. So whatever you do to one side, you have to do to the other. So we have to take the square root of this side as well. So the square root of x squared is going to be simply x. And the square root of 225, when you take the square root of 225, if you need to, you can use your calculator if you don't know that basic fact. So then we just want to do 225 and then find the square root symbol on your calculator. Each calculator may be just a little bit different. And we find that 15 is the square root of 225. So then we can say that x equals 15. Now, it's important here to think about a little bit what happens when we take a number and square it. Okay, so for this, I'm going to go to another page. We're going to do another example. When I take 3 and I square it, I get 9. Okay, but when I take negative 3 and I square it, now notice I put parentheses around it because I'm squaring negative 3. I get negative 3 times negative 3. And what I have here is a negative times a negative, which I know is a positive. So 3 times 3 is 9. So actually negative 3, that whole thing squared, is going to give us a positive 9. So if I do either negative 3 squared, that equals positive 9, and also 3 squared equals positive 9. So what that tells me is that when I look at this problem, I know that since I'm squaring it, if I had 15 squared, I would get 225. But I also know that if I had negative 15 squared, I'm also going to get 225. So that means the solution is not only positive 15, but also negative 15. So we know that we have to add plus or minus to have the complete answer for this problem. So that's going to be key for us, is that knowing and remembering whenever we're solving for a variable squared, we're going to have two possible answers, both the positive and negative. So another example of that would be a squared equals 16. Okay, you take the square root of both sides, and we know that a equals 4, but not just 4, but positive and negative 4, because negative 4 squared is going to be positive 16. And so we want to make sure that we include that possibility. We don't know, because a variable is unknown. We don't know what a is. So it's kind of like that number machine, and you're trying to figure out what number was put in order to get this. And so if your problem is a squared equals 16, well, you can't tell me for certain that a is 4, because a actually could be negative 4, and the answer would still be 16. So you want to make sure that with your answers, you're giving me all the possible outcomes for that solution. So, for example, number 5, the artwork on the square picture in a compact disc case is approximately 14,161 millimeters squared in area. Find the length of each side of the square. So again, we are talking about a square picture. It's not a rectangular or anything like that. So when I think of the formula for a square, the area of a square, I'm going to have a equals f squared. okay, because when I think of a square, all the sides are equal, so I can say S and S, and so I do S times S. Well, S times S equals S squared. So that's why I say A equals S squared. And we know that the area equals 14,161. So 14,161 equals S squared. So we want to find out what is the length of each side. So we don't want to find out what S squared is. We want to know what S is. So we need to take the square root of both sides. And we know that the square root will cancel out the square. So S equals, and we'll go to our calculator here and do 14,161, and we'll find the square root of that, and it comes up with 119. So we'll go back to our page here. 119, and then we need to make sure we have some units. So 119 millimeters. We know they're not going to be millimeters squared because we're no longer talking about area here. We're just talking about what one side length is. And then one other thing here is we need to discuss what we just talked about in solving for square values. Here I said that, 3 squared is 9 and negative 3 squared is 9. And so what I've kind of told you here for a rule is that whenever you solve for a variable squared, you're going to have two possible values. You have the positive and the negative. So when we look at this problem, we see that it is S squared. So we want to think, do we want to say positive and negative 119? Well, theoretically, positive and negative 119 squared does give us 14,161, okay? But we need to think about the context of this problem here and understand that we're talking about a distance, and we've talked about before that distance cannot be negative. So here the only possible value for us is 119 millimeters, and that's a positive 119, because we wouldn't be able to talk about a negative 119 millimeters for that being the length of a side of a square. That just wouldn't make sense. So in this case, we can leave out the negative value, even though negative 119 squared does equal 14,161. The answer, negative 119, just does not make sense in this problem. And that is our last example for this lesson. If you have any other questions or want some more examples, please refer to the tutors that I've listed above. You can also take a look at the step-by-step homework helper for more help with all the odd number problems in the book, or otherwise we can just ask for other help in class.